Continue with our applied electricity video series. Today we'll be looking at Thevenin's theorem. So, welcome to Atiigah Tech Academy. In this video, we'll look at Thevenin's theorem, one of the most powerful techniques for simplifying complex electrical circuits. We'll take a step-by-step tutorial. This step-by-step tutorial will guide us through the basic concepts of Thevenin theorem. When they give us a complex circuit, we simplify it to the Thevenin circuit. Then how to find the Thevenin equivalent circuit, that is Thevenin voltage and Thevenin resistance. And finally, we'll solve some examples to help you master the techniques. So whether you are preparing for exams or you want to strengthen your fundamentals, this video has everything you need to understand and apply Thevenin's theorem with confidence. So please don't forget to like, share, and subscribe for more tutorials. So without wasting much time, let us dive in. So when we say Thevenin theorem, I know they might have already explained it to you in class. So with Thevenin theorem, they will give you a complex circuit, and these are the processes that we use to solve Thevenin theorem. So let's say if they give you, Thevenin says that when they give you a linear circuit, any linear circuit, so when they give you a linear circuit, they will ask you to find a current through a particular resistor. So to find the current through that particular resistor, the first thing we do, he says we should remove the resistor from the circuit in which we want to find the current through it and mark the two terminals. So after removing the resistance, he said we should find the open circuit voltage, also known as VTH, across the two terminals that we have removed by applying KVL. And that we should treat VTH as a source. We remember that from KVL we said we have voltage sources and voltage drop. So in this case, they are telling us that we should treat VTH as a source. We shouldn't treat it as a voltage drop. So we have to keep this in mind. And they said, recall the circuit created before step 2. So we'll go back to step 1. We'll go and pick the circuit that was given to us in step 1, and we deactivate all sources. So meaning if it is a voltage source, we short circuit the voltage source, and if it is open, and if it is a current source, we open circuit the current sources. That is all about it. Then we find the total resistance of the circuit resulting from step 3 as seen from the two terminals. Then finally we draw the Thevenin equivalent circuit and calculate the Thevenin the current through it. So the Thevenin equivalent circuit, it simply says that any linear network can be converted to the load resistor in series with the Thevenin resistance. So the Thevenin resistance is represented as RTH, and the Thevenin voltage is represented as VTH, and this will be our R load. So basically, if we want to find the current that will be passing through this circuit, we can simply say the current through this branch, IL, is equals to our VTH all over our RTH, because the RTH and the RL are in series, plus this, that will be the current. So basically this is just, I just want you to understand here. So let's take a practical example and we'll see how things go from here. So this is a circuit I want to use it to explain to you guys. So let's say they've given us this circuit and they are telling us that we should find the current that is passing through this R, the load resistor RL. We should find the current that is passing through RL. But Thevenin principle tells us that we should remove the resistor we are looking for, the resistor that we are calculating. We want to find the current through it. We should remove the resistor from the circuit. So after removing the resistor from the circuit, we come and get this, our figure here. We've removed it and we've named it VOC or VTH. So let me name it VTH. So after naming it as VTH, we will now calculate VTH. So how do we calculate VTH? We can perform KVL here and also perform KVL here. So perform KVL in this loop and perform KVL in this loop. So basically they said we should also treat VTH as a source, that is to find VTH. So let's say if we wanted to find the VTH here, so for the first loop we would say the voltage which is given to us as E here is equals to R1 plus R2 times the current, because I went in a clockwise direction. That is our equation. So basically we can say I here is equals to our E, which is the voltage, times R1 plus R2. Then if we want to also find our VTH here, we are taking the loop in an anti-clockwise direction. So we say our VTH here, voltage source, we are treating it as a voltage source, is equals to, we are going in the anti-clockwise direction, is equals to I times R2. So if we know the value of R2, we can simply find VTH here. So basically that is how we find VTH. We just apply KCL. After removing the resistor, we apply KCL to find VTH. Then they said afterwards we need to find RTH. And to find RTH, they said we should short circuit all voltage sources. So there was realize that there was a voltage source here. So I've short circuited it. And if there is a current source, then we should open circuit it. So since there's no any current source, it's only one voltage source, I've short circuited the voltage source. And after short circuiting the voltage source, we are looking through here. Look at the picture here. The person is looking backwards. So when you look backwards, you realize that R1 and R2 are in parallel, because, or we can say I can circle these two resistors without meeting any third element. So meaning R1 and R2 are in parallel. So I can say my RTH here is simply equals to R1 is in parallel with R2. So RTH here is equals to R1 times R2 all over R1 plus R2. So basically this is everything about Thevenin's theorem. So they give you the circuit, you remove the resistor, find VTH, use KVL to find VTH, but we treat VTH as a source. Then we deactivate voltage sources, we short circuit voltage sources, open circuit current sources, and we find the Thevenin's resistance. So after finding the Thevenin's resistance, we found VTH and RTH. So we draw our equivalent circuit here, our RL here. So this is our VTH now. Our RTH we've been found it, and our RL. And we now have to find the current. Let me use a different color. So the current through this I here, IL, is now equals to our VTH all over RTH and RL are in series plus this to find the current through it. So basically that is how we find the current through this. So I'll take an example and I'll use it to explain so that we will really understand what is going on here. So we have problem 1. So problem 1 says we should find the current through the 5 ohm resistor. So I told you already, this 5 ohm, this is the 5 ohm resistor. So the first thing you do is you remove the 5 ohm resistor from the circuit. So after removing the 5 ohm resistor from the circuit, you mark the 2 terminals. You just remove it from the circuit. So we remove it from our circuit. This is our question, and we remove it from our circuit. So they said all resistance are in ohms. So first of all, what do? We first of all have to calculate VTH. So I name my VTH here. I write my VTH here. My VTH is here, and the direction is this way. So we realize that we have to apply KVL in every loop in order to be able to find it, because there is a loop here. This is a loop. This is a loop. So I'll also give my direction. I'll take the direction in a clockwise direction, and I'll take my direction here in an anti-clockwise direction. So basically let's use KVL to find the current through this. So let us name the current passing through this as I1 and the current passing through this as I2. So applying KVL at the left side. So this is the left side and this is the right side and this is the middle. So with this one too, if I want to perform my KVL, I'll go this way in this direction, in the anti-clockwise direction, because I'm just following the flow of VTH, because I'm saying VTH should go to this direction. So to find VTH, I'll first of all take the loop, this loop. So we realize that we're moving from a lower potential to a higher potential, so that is a rise in voltage, making 7 positive. So we have 7 here is equals to, this current is going, the I is going in the clockwise direction, so the drop here will be 2I1, and the drop here, the same current will also flow here. We realize that here, because there's an open circuit and we get it will not split, so it simply becomes 2 plus 3, that becomes 5I1. So we'll do it as 2 plus 3 to bracket I1. So we have 7 here is equals to 5I1. So I1 is equals to 7 over 5 amps. We found I1. So let us also apply KVL at we apply KVL in the second loop. So applying KVL in this loop, we said we are going in the anti-clockwise direction, and going in the anti-clockwise direction, we realize that we are moving from a higher potential to a lower potential, which is minus 10. So meaning here will become minus 10. So if here becomes minus 10, the voltage drops there are 2 and 2, that makes it 4. So applying KVL in that loop, I'm using a different color. Applying KVL in this loop, I have minus 10 is equals to 2 plus 2, 2 plus 2 I2. So we can say I2 here is equals to minus 10 over 4 amps. So after getting our minus 10 over 4 amps, we now have to find VTH. And how do we find VTH? We can find VTH by applying KVL in this loop. So we realize that what current comes here, when current starts to flow, current will pass through this I1 comes here and I2 also comes here, but realize that this 2 ohm resistor, no current will pass through it, because when current starts flowing from this minus 7, this 7 volts, it gets here, it doesn't split because there's an open circuit here, it just passes here all the way back. When this one also starts to flow, it gets here, it doesn't split, moves to this place, it doesn't split all the way back. So when we are analyzing, these 2 ohms wouldn't receive any current. So we said sum of voltage sources is equals to sum of voltage drops. So I will say when we are going in the anti-clockwise direction, and VTH is also going in the anti-clockwise direction, so VTH is equals to 3I1 and I2 is going in the opposite direction. You see the arrow I2 here, I2 is coming down here and we are going in the opposite direction, so we have to negate it. So it now becomes minus 2I2. We found the value of I1 and I2 already. So we now say our VTH is equals to 3 times our 7 over 5 minus 2 times minus 10 over 4. So after doing everything, we'll get our VTH to be equals to 9.2 volts. So VTH is now equals to 9.2 volt. And from our next step, they said we should after finding VTH, we need to find RTH. To find RTH, what do? We deactivate all the voltage sources. So we short circuit voltage sources. So you see the 7 here. Here it has been short circuited. Here it has been short circuited. So here we now need to find RTH. And looking at this, we realize that this 2 and this 3 are in parallel. This 2 and this 2 are in parallel. And they are in series with this. So 2 and 3 are in parallel, in series with 2. And they are all in parallel with 2 and 2. So basically, I can write it as RTH here is equals to 2 parallel 3 this plus 2 plus 2 parallel 2. So after writing it like this, I can now do the mass. RTH here is equals to 2 times 3 all over 2 plus 3 plus 2 plus 2 times 2 all over 2 plus 2, which is equals to 4.2 ohms. So we now know our RTH as 4.2 ohms. So since RTH is now equals to 4.2 ohms, we now draw our Thevenin equivalent circuit. So our Thevenin equivalent circuit is our VTH, which is the voltage source, in series with our load resistor. The resistor we moved was 5, and our RTH is 4.2. VTH is 9.2. So we are now finding the current. So I here would be equals to our voltage, which is 9.2, all over our resistors in series, 4.2 plus 5, which is equals to 1 amp. So basically, this is how we solve Thevenin's problem. So when we move to the next example, I know it will go a long way to help us. Next example. So basically, these are the answers here. So if you want to. So with our next example, they are saying using Thevenin's theorem, find the current in the 0.1 ohm resistor. All resistances are in ohms. So with this circuit, realize that this is 100 milliamps, 100 milliohms. 100 milliohms simply means 0.1. So basically, it's the same. So the m here is milli, that is 100 times 10 raised to the power minus 3. So here too, that is 0.5. Here too, this is 0.4. Then we have current sources. So our first current source is 5. This is 5. So they said we should find the current through the 0.1. So to find it, we've taken it out. And taking it out, we have to now perform our analysis. So to perform our analysis here, we would need to take assign our currents. So this 5 amp, when it gets here, it doesn't split. The 5 amp flows through the 0.5, and this 2 amp, when it gets here, it also flows through this. So we name here our VTH. So our VTH will take a loop in the we'll take a loop in the clockwise direction, anti-clockwise direction. Sorry. So we are taking our loop in the anti-clockwise direction to find VTH. Since here they've given us the current, so it's simply straightforward. We know the currents already. So we can say VTH here. To find our VTH is equals to our 0.5 times 5, because 5 amps is entering, times 5 minus 0.4 times 2. So basically this is what we get. Then we end up by getting VTH equals to 1.7 volts. So we've just gotten VTH. Then the next step, we have to find RTH. And RTH, they said to find RTH, we short circuit voltage sources and open circuit current sources. So open circuit means we should open here. So let's say if current starts to flow from here, it gets here, it doesn't split, it just take this path, moves here and move back. So to find our RTH, let us move. We realize that this one, the 0.5 and the 0.4 ohms, they are all in series. So our RTH here is equals to 0.5 plus 0.4. So our RTH here is equals to 0.9 ohms. After doing this, we simply we find the Thevenin equivalent circuit. And the Thevenin equivalent circuit is this. Our VTH in series with our load resistor. So our I is here, and the resistor we removed was 0.1, and our RTH was 0.9. Our VTH was 1.7. So we now find our I as 1.7 all over 0.9 plus 0.1, which is equals to 1.7 amps. So basically this is how we solve this question. So you can take your time, can pause the video, leave a comment. If you have any suggestions, leave it there, then we are good to go. So let us move to our next problem. And our next problem is this. You might see this problem to be complicated, but after I'm done analyzing the circuit and doing everything, you'll be like, oh really, it was simple like this. So first of all, realize that we have a 24 voltage source here. So with this 24 voltage source, let's say when current is being delivered, when current gets here, it's placed into two. Some passes through this 3 ohm resistor, 4.5, and this 4.5, and some also come here, pass through this 3, 6, and 9. So let us name the current going up here I1, and the current coming here I2, because it was split here and split here. So the current going up is I1 and the current coming down is I2. So basically that is the question, but they said we should find using Thevenin, find the current in the 5 ohm resistor. So to find it, we have to remove the 5 ohm resistor. So after removing the 5 ohm resistor, let us do our assignment here. So we say the current coming here should be I1, the current coming here should be I2, because since we've removed this to find VTH is here. Since we've removed this, that means when current gets here, when current gets to this node, it will not split. It just moves in one direction, and here they combine and they come back. Here too, they move in one, get here, combine, and they come back. So basically that is it. So we can take two loops here. So we can take a loop. So we can take a loop because I1 flows through this 3, flows through this 4.5 and flows through this 4.5 and all the way back. So basically we can write a loop equation for that. So we can say when this 24, we can say taking the loop, let me use a different color to represent that. So we are just taking this loop, we are taking this loop, we are taking this loop because the current will flow from here, then to here, then both of them will come and combine, because this one, and we'll also write an equation for this loop, this second loop, because you see they come and combine here. They come and combine here, they come and combine here. So since they are coming to combine here, we'll write two loop equations. So to write two loop equations for the purple one, for the first one, for I1, we can say 24, that is the voltage source. Voltage sources is equal to sum of voltage sources is equal to sum of voltage drop, is equals to our 3I. We realize that all these resistors are in series. I don't know if you, because this 3, the same current I1 will flow through 3, 4.5 and this 4.5. I hope you are seeing what I'm saying over here. So basically that is it. So it becomes 3 plus 4.5 plus 4.5 times I1. So basically I1 here is equals to 24 all over 12, which is equals to 2 amps. And we can also write the same thing, another equation for this side, starting from here. Then I take this 3, because this 3, I2 is flowing through this 3, this 6 and this 3. So I2 flows here from this. So I will say 24 here is equals to 3 plus 6 plus 3 I2. Then also calculate for I2. After calculating, also realize that I2 here is equals to 24 over 12, which is equals to 2 amps. So we've now found I1 and I2. Now they said we should in order to find we now need to find the total distance, the total resistance, that's RTH. We have to find RTH. So we have to find RTH in this circuit. So sorry, I left something out. We've not found VTH. We are looking for VTH. So we have to find VTH. To find VTH, we can take a loop. You realize that when we take this side, so to find VTH is basically simple. So VTH will take this loop. Realize I see we'll take this loop from here to this and back, because VTH is basically this right angle triangle. So we take this side, this 3I2, this 3I1 and 4.5, because this we can, when I guess here it comes. So we can write our VTH as VTH here is coming, we are taking the clockwise direction, and I2 is going in the opposite direction. So VTH is equals to minus 3I2. Then I1 is going in the correct direction, because I1 is going this way clockwise. So it becomes plus let's just add, because this 3 and this 4.5 are in series, so that becomes 7.5. So it becomes 7.5 I1. So that becomes our equation for our VTH. So VTH here is now equals to minus 3 here times 2 plus 7.5 times 2. Then we finally get our VTH as 9 volts. After getting our VTH as 9 volts, we now need to find our RTH in order to be able to calculate for the current that was passing through the 5 ohms resistor that we removed. To find our RTH, we short circuit all current sources, all voltage sources, and open circuit all current sources. And we only have one voltage source here, which is the 24 volts. We've short circuited it, and we'll come to realize that, you see, when current gets here, is split. This 3 and 4.5 are in series, so this becomes 7.5, and it is in parallel with this 3, you see, and this 6 and 3 are in series and in parallel with this 4.5. So basically that is our analysis here. So let me redraw the circuit. So I've redrawn the circuit here. So you see that 3 and 4.5 are in series and they are in parallel with this 4.5, and this 3 and 6 are in series and they are in parallel with this 3. So basically our RTH here is equals to 3 sorry, let's just add the 3 and this thing, 3 and 4.5. It becomes 7.5 in parallel with 4.5 plus 3 plus 6 becomes 9 in parallel with 3. So basically our RTH becomes 7.5 times 4.5 all over 7.5 plus 4.5 plus 9 times 3 all over 9 plus 3. We end up getting our RTH as 5.0625 ohms. Then after doing this, we'll draw our Thevenin equivalent circuit. Drawing our Thevenin equivalent circuit is a Thevenin voltage in series with our load resistor. So our RTH is 5.0625. Here was 9, our VTH is 9, and the resistor we removed was 5 ohms. I said the 5 ohms resistor. So here is 5. So the current through the circuit is now, our I here is our 9 volts divided by our resistors in series, 5.0625 plus 5 here is equal to 0.894 amps. So we get 0.894 amps as our final answer, and that is how we solve this question. So you can take your time, pause the video and go through it. So this is our final answer here. Okay, so problem 4 says we should find we're using Thevenin theorem, find the current in the 10 ohms resistor. So according to Thevenin, he said we should remove the resistor in which we are looking for the current through it. So we should remove the resistor from the circuit. And after removing the resistor from the circuit, we name here VTH. So we'll take our loop in an anti-clockwise direction. Then here we'll take our loop in a clockwise direction, because basically there are two voltage sources here, this and this, and if current is going to move from, if the current that is being delivered from here, when it gets here, when it gets to this node, it doesn't split, all moves back here because there is an open circuit here. There's an open circuit here, so it just moves in one path. There's no splitting. So That is it. So applying KVL to that loop, we realize that this voltage moves from a lower potential to a higher potential, that is a plus, and going in the clockwise direction. This voltage also moves from a higher potential to a lower potential, making it a negative. So let us name the current through this as I1, because the same current will appear here. I1 will appear here, and the same I1 will appear here because it will be one current passing through the whole circuit. So writing the loop equation for that, writing KVL for that, we have 10 minus 12 here is equals to, because the 10 minus 12, that's the voltage sources, is equals to voltage drops. We have 4 and 6 are in series, so the same current flows through them, I1. So we have minus 2 here, we have minus 2 here is equals to 10 I1. So we can say I1 here is now equals to minus 2 over 10. Then we get I1 as minus 0.2 amps. After finding the value of I1, we simply need to now write the equation for the second loop going in the anti-clockwise to find VTH. So we realize that VTH is moving in the anti-clockwise direction, and this one is also moving in the anti-clockwise direction. So basically we have our VTH. VTH is voltage sources. Those are voltage sources. So it's simply sum of voltage sources is equals to sum of voltage drops. So, and we realize that we are moving from a higher potential to a lower potential, so it becomes negative. So the 12 becomes negative. So we have our VTH here minus our 12 here is equals to 6 I1. So VTH here now becomes VTH here now becomes is equals to 6 I1 plus 12. So VTH is equals to 6, I1 is equals to minus 0.2 plus 12. When we do the mathematics, we'll get VTH equal to 10.8 volts. And after doing this, Thevenin said to find the RTH, the resistance through the circuit, we should short circuit voltage sources. This is our voltage, so we have two voltage sources, so let's short circuit them. So short circuiting the voltage sources, we now end up getting only this equation. Realize that the 4 and 6 are in parallel, so our RTH here is equals to 4 times 6 all over 4 plus 6. So our RTH becomes 2.4 ohms. Then we will now finally draw our Thevenin equivalent circuit, which is the RTH in series with our with our load resistor. So here is 2.4 and the resistor we removed was 10. So now to find the current through the resistor, I here, VTH was 10.8 volts. This was ohms. So now to find I is equals to 10.8 all over 2.4 plus 10. Then we get our I as 0.87 amps. So basically that is how to calculate for this. So let us move to our next example. So with our next example, they said we should find the Thevenin equivalent circuit between the terminal A and B. So we see these are the terminal A and B. This is A here and B here. So we should find the Thevenin equivalent circuit between A and B. So what do we realize? We realize that this circuit, I can redraw this circuit. So I'll flip this side. So I'll bring this side to the bottom and take this side to the top. I'm just flipping the circuit. I'm changing it, so I'll flip it so that the A and B will be in the same direction. So I flipped it and I've redrawn the circuit like this. So basically this circuit is same as this circuit. It's just a wire that I flipped the wire. I flipped the arrangement of the wire. So they are just telling us here we don't need to find the current, we just need to find our RTH and our VTH, and we are done for this question. So after finding RTH and VTH, we are done. So here we realize that after flipping the equation, we have our 20 volts here, and our A and B now becomes like this. Here becomes our A, here becomes our A, and this becomes our B. So basically our VTH is here. So we have to apply 3 loop equations, so I will use different colors. So we'll apply a KVL here, and we'll apply KVL here. I usually choose the direction per what I want, so you can choose a different direction too, but you might end up getting a negative answer. You get the same answer, but sometimes it might be negative because of the direction you choose. Yeah, if you choose the opposite. So let us name the current that this one delivers as I1, and let us name the current that this one delivers as I2. Realize that when this one delivers from here, when it moves from here to here, they are all in series. It gets here, it doesn't split because there's an open terminal here. It just come back. When this one also delivers from here to here, it comes back. So let us write our loop equations. So we realize that for the first one, we have our voltage source is 20 is equals to 8 plus 12 I1. So we have I1 is equals to 20 divided by 20. So basically, which is equals to 1 amp. We have 1 amp here. And applying KVL to this side to the right hand side, we are moving from negative to positive. That is a rise in voltage. So we equally have our 20, that's our voltage source, our 20 is equals to our 9 plus 1 times I2. So I2 here is equals to 20 divided by 10, which is equals to 2 amps. So here we've now found the value of I1 and I2. What we simply need to now find is KVL. So we take a loop, and we are taking the loop in the anti-clockwise direction. We know that I1 passes through this 12, and this one also is I2. So we are treating VTH as a source. So VTH here is equals to, we are going in the anti-clockwise direction. So here is also going in the anti-clockwise direction. So it becomes 12 I1. Then this one is going in the opposite direction, opposite to our movement. So it becomes minus I2. So our VTH now, we just substitute 12 times 1 minus 2. So VTH here is equals to 10 volts. And after doing that, we need to now find RTH. And RTH, they said we should short circuit all current voltage sources. So this voltage source has been short circuited. That's why we now have this and this. So what do we realize? To find RTH, realize that this 8 and this 12 are in parallel, and this 1 and this 9 are also in parallel. So we simply calculate them, and we just add them. Of course, after calculating them, they'll all be in series. So our RTH now is now equals to 8 times 12 all over 8 plus 12 plus 9 times 1 all over 9 plus 1. So our RTH is now equal to 5.7 ohm. And after doing that, we now draw our, they said we should find the Thevenin equivalent circuit. So we'll draw our Thevenin equivalent circuit. Then we'll just put our values there. This is terminal A, this is terminal B. So here was 5.7 ohms and here was 10 volts. So basically we are done with this circuit. So let us take the next, our last problem for this video series, and we are good to go. So with our last we need to find the Thevenin, using Thevenin, find the current in the 4 ohm resistor. All resistances are in ohms. So just as we used to do, we'll take out the resistor out, and after taking the resistor out, we'll realize that we'll open the terminals. After opening the terminals, after taking the 4, we just assign our currents. So here we'll do our current assignment. So let's say the current that this one delivers, let's name it I1. And here the same I1 will flow here, and we name here VTH. So VTH, with our VTH. So now to find for VTH, we can also take our loop in this direction. So we realize that, and we're also taking our loop here in this direction, all clockwise. So we realize that our voltage sources in the first loop is equals to 15, which is equals to, we have only one voltage source, is equals to our 10 plus our 5 ohm resistor. I1 is passing through them, so I1 here becomes 15 on 15, which is equals to 1 amp. Then also apply KVL to this second loop to find VTH. So here in the clockwise direction, we meet the voltage source. The first voltage source is VTH. So we have VTH here. Then we see we are moving from a higher potential to a lower potential. So from this 6, we are moving from a higher potential to a lower potential. So it becomes -6. So -6 is equals to, we have only one source here, which is the 5, and the 5 is going against our flow. So we are going in the clockwise direction, but 5 is coming in the anti-clockwise direction, so it becomes -5 I1. So our VTH basically becomes is equals to 6 minus 5 times 1. So our VTH now becomes 1 volt. So basically VTH is now 1 volt. And after finding VTH, they said we should find RTH. Finding RTH means we should short circuit voltage sources. This is a voltage source, so we should short circuit it. So here we've short circuited it, and we now have our circuit as this. So our RTH, finding RTH here, we look through these terminals. Then we realize that the 10 RTH here is now equals to, the 10 and 5 are in parallel, all over 10 plus 5, which is equals to 10 over 3 ohms. Then we simply draw our Thevenin equivalent circuit, because we now have our VTH, we have our RTH, and we have our load resistor that we need to. So here is 10 over 3 ohms, and here is 4 ohms. It was 4 ohms, and our voltage was 1 volt. So the current through it is equals to our 1 all over 10 over 3 plus 4. So I will now be equals to 0.1364 amps. So this is how we solve Thevenin's problems on Thevenin's, and how to solve it. So basically these are some tips you will need. So basically we know that with Thevenin, after solving it, you have to reproduce the Thevenin equivalent circuit, and after producing the Thevenin equivalent circuit, you can now find the current read. So basically sometimes when you are having issues with solving the VTH first, sometimes me advise you can solve RTH, because you just solve the RTH first, then it will give you a fair idea, then you come and solve VTH. See that it's really simple. Thevenin is really simple. So thank you very much for watching. Kindly share this video, like, comment, leave a comment, and subscribe, because your subscription really helps a lot. It motivates me to know whether you really like the content we are producing or not. So kindly stay tuned and tune for our next video. Our next video will be covering Norton's theorem. So thank you very much for watching, and please like, share, and subscribe. And this video was being taught by Atiigah. You can email us in case you have any questions or you need further clarification. You can email us. This is our email address. And in case you want to also reach the episode tutor, this is his phone number. You kindly feel free to reach out to him. So please kindly like, subscribe, and share. Thank you very much, and God bless you. And this is the best video you will need to prepare for any kind of exams, whether be it mid-sem, end of sem. This video, I know the tricks here has gone a long way to help you guys. So thank you. I'm signing out.